Good afternoon once again, and today we continue the chapter. Today, the second day of the chapter 9, that is hydrogen, 22nd of October 2021. It's a Friday. Now, in the previous class, I was talking about a little bit about hydrogen peroxide, the preparation of hydrogen peroxide. Today we'll be learning in more detail about hydrogen peroxide with regard to its physical and chemical properties. Now, on page 578. The concentration and storage, this is not required. This part is not required. Okay, you may leave it out. Okay. What is required, I'll let you know. Storage is also not required. Storage is not required. Now, properties are required. Properties of hydrogen peroxide. Let us go through this detail. Physical properties. Now, pure hydrogen peroxide is a colorless syrupy liquid. It is colorless, but it is a syrupy liquid, like a syrup. It is colorless in small amount but appears bluish in bulk. If it is concentrated, the color becomes bluish. It has a bitter astringent taste. Bitter astringent taste. Bitter astringent taste. Now, what is astringent? Tell me. What is astringent? Anybody? What is the meaning of astringent? Huh? Like when you taste lemons or pickles and all, no? When you taste lemons, concentrated lemons or pickles, you try to contract your mouth, isn't it? Acidic, bitter, slightly acidic, you can say. Okay, so if you apply, say, to the skin some lotions, okay, like suppose if you hurt yourself while playing on the ground and you apply some Dettol on the wound over there, there is a sharp feeling which comes to your body. The pain is there, bitter. Okay, so that is bitter astringent taste. Hydrogen peroxide, the fourth one, it is completely miscible with water, alcohol, and ether in all proportions. It has a higher density than water. High density is due to the presence of, it is because of the presence of over here intermolecular hydrogen bonding. So high density of hydrogen peroxide is because of intermolecular hydrogen bonding. Its melting point is 272 Kelvin, below 0 degrees Celsius, and boiling point is 423.2 Kelvin. This hydrogen peroxide is injurious to skin and produces blisters because of oxidizing nature of hydrogen peroxide when brought in direct contact with the human skin. Okay, so table 9.4 will give us some physical constant with respect to density, solid, liquid, melting point, boiling point, and so on, but these are not necessary to be studied. We come to the important thing in this chapter, that is chemical properties of hydrogen peroxide. That is more important. Now, the first one is decomposition. Pure hydrogen peroxide is not very stable. Please keep in mind. It decomposes into oxygen and water on standing or on heating. So if you keep a container of hydrogen peroxide open, or if you warm it up, warm it up, it will decompose to give water and liberate oxygen gas. This decomposition is an example of auto-oxidation reduction reaction, as is clear from the following over here. So have a look over here. Hydrogen peroxide oxidation number of oxygen is -1, whereas over here it is -2. Over here it is 0. So it is reduction. Reduction is happening over here because there is a lowering of oxidation number. The decomposition of hydrogen peroxide is catalyzed by the presence of manganese dioxide or carbon or dust particles, organic tissues, finely divided metals, and certain metal ions. On the other hand, substances like phosphoric acid or glycerol or acid anhydride, etc., suppresses its decomposition and thus act as a negative catalyst for its decomposition. So, if you want to preserve a bottle of hydrogen peroxide, think about adding little bit of phosphoric acid or glycerol or acetanilide to the solution of hydrogen peroxide and store it tightly capped in a container. Now, this was the first chemical property. After this, moving to the oxidizing properties. Now, why is hydrogen peroxide oxidizing in nature? It is a powerful oxidizing agent in acidic as well as in basic medium. The potential equation describing its nature as an oxidant is given below in acidic medium. So, in acidic medium, it is forming water. It is forming water. Now, these two electrons are used by the hydrogen peroxide to produce hydroxyl ions. That's how it is showing its what do you call oxidizing nature. Now, some important, very important reactions which is required by you all to learn from this chapter, from this hydrogen peroxide. I'm telling you, okay. So please mark them and better learn them properly. So the following reactions only, not other reactions. Okay, the first one is under oxidizing property. The first one is it oxidizes lead sulfide. This is required. It oxidizes lead sulfide black to lead sulfate, which is white in color. So you better learn this equation. The equation is on the next page over here. You learn this equation, this part. Lead sulfide with hydrogen peroxide, it is producing white colored lead sulfate and water. So learn this final equation directly. Okay, this is the first equation to be learned. The next equation to be learned is it oxidizes potassium iodide to iodine. Potassium iodide to iodine is below. Potassium iodide to iodine is below over here. This equation. So this one. It oxidizes potassium iodide to iodine. So you learn this equation. 2Ki plus H2O2 is forming potassium hydroxide and iodine. All are important equations. Okay. This is the second oxidation reaction. Then the next important reaction is for the reaction of hydrogen peroxide with uh, what do you call ferrous sulfate solution. So here again you learn the final equation which is given over here. Ferrous sulfate solution with hydrogen peroxide acidified, it gives ferric sulfate and water. So these are the three oxidation reactions of hydrogen peroxide which you have to remember. And then after that, if you come down, if you go to the next column over here, the next important reaction which is to be learned is under reducing properties. Under reducing properties, why is hydrogen peroxide reducing? It also acts as a reducing agent both in acidic and alkaline mediums. The potential is mentioned over here. In basic medium, this hydrogen peroxide reacts with hydroxyl ions to give what we call water, oxygen, and two electrons are given out. These two electrons act as reducing. Okay, so the important reducing reactions which are to be learned by you all, I'm telling you. The first one is it reduces chlorine to hydrogen chloride. It reduces chlorine to hydrogen chloride. This one, number three, this one. It reduces chlorine to hydrogen chloride. So you learn this equation directly. H2O2 plus Cl2 will give you twice HCl plus O2. So this is the first reducing reaction of hydrogen peroxide. The next one is it hydrogen peroxide decolorizes acidified potassium permanganate solution. This one, number four. Number four, it decolorizes acidified potassium permanganate solution. So you try to practice the final equation over here. This equation. When you react acidified potassium permanganate with hydrogen peroxide, it forms potassium sulfate, manganese sulfate, water, and oxygen is liberated. So these are the only two reducing reactions over here, which is important. There is one more, that is number 7. If you look at number 7 after number 4, come down to number 7 over here. This is also asked sometimes. Number 7, it reduces lead dioxide to lead monoxide, that is litharge. So you learn this equation. Lead dioxide with hydrogen peroxide, it becomes lead monoxide. So this is a reducing action of hydrogen peroxide. So these are the important reducing reactions of hydrogen peroxide. After that, the next thing which is required uh, over here uses of hydrogen peroxide. How is hydrogen peroxide used? The main uses, okay, the main uses. The first one, it is used for bleaching delicate articles such as wool, silk, hair, ivory, feathers, etc. It destroys bacteria. Therefore, it is used as an antiseptic and germicide for washing wounds, teeth, ears, etc. Since it oxidizes lead sulfide to lead sulfate, it is used for restoring the color of lead paintings. Number 4, it is used as a propellant in torpedoes, submarines, and rockets. Number 5, it is used as an oxidizing agent in the laboratory. So, try to go through these uses of hydrogen peroxide. Now the next important thing which is there in the syllabus is with regard to structure of hydrogen peroxide. This is mentioned in the syllabus. It is important. After doing extra studies and studying the dipole moment of hydrogen peroxide, it has been found that it has non-planar structure as shown in figure 9.8 on the next page. In the gas phase, I'll show you on the next page, the dihedral angle is 111.5 degrees, which reduces to 90.2 degrees in the solid state due to what? Hydrogen bonding. So it is all a case of hydrogen bonding happening. Now, if you look at the next page, the diagram, the structure of hydrogen peroxide, you can see over here very carefully. There are two diagrams. This is one diagram, this is another diagram. In the first diagram, this is the structure of, this is A in the gas phase. In the gas phase, if you look at this angle it is 94.8, whereas this angle is 111.5 in the gas phase. And this length over here, oxygen length is 147.5 picometer, okay, in the gaseous phase. But if you look at the what do you call in the solid phase over here, the bond length is slightly lowered, 145.8 picometer between the two oxygen atoms, okay. And then this angle is become more in the solid phase, 101.9 degrees. This angle has become less, 90.2 degrees. And this length is also, it is increased, 98.8 pm. So this is how you have to try to remember the what do you call the two structures of hydrogen peroxide. The two structures of hydrogen peroxide, one it is in the gas phase and the second one is in the solid phase. This difference in the bond angles and the bond length, it is all because of hydrogen. It is all because of what? It is all because of hydrogen bonding, okay, because the two oxygen atoms are linked together by a single electron pair bond. This linkage is called peroxide linkage. If you look over there, if you look over there, this linkage which you see, this oxygen, okay, hydrogen, this linkage which you see, it is called peroxide linkage. Peroxide, it is called peroxide linkage. That is important. Okay. After that, uh, there are some numericals. There are some numericals which is required. Okay, like strength of hydrogen peroxide. For this, I'll just try to explain you as percentage. Look at this as percentage. The strength of hydrogen peroxide may be expressed as percentage of hydrogen peroxide present in the given solid. For example, if you take a 30% solution of hydrogen peroxide, means what? 30 grams of hydrogen peroxide are present in 100 grams of the solution. Please remember this. Okay, that is as percentage. And the next method of expressing the strength is in the terms of volume. For example, if you take say 10 volume, you can take 10 volume, or you take 20 volume or 30 volume. For this volume, to understand this, if you look at the bottom over here at STP, if you take a 10 volume solution of hydrogen peroxide, means that 1 liter of the given hydrogen peroxide solution will give 10 liters of oxygen gas upon decomposition. This is what you have to remember over here. Okay, so here it is mentioned over here very clearly, 10 liters of oxygen at STP. the decomposition reaction of hydrogen peroxide can be written over here. So if you take 10 volume, if you take 10 volume over here, what do you call 10 volume of solution of hydrogen peroxide means 1 volume of hydrogen peroxide will give you 10 liters of oxygen at ST. Okay, so based on this, there are some numericals given over here. Example 9.1. So here, example, if you look at example 9.1, it is told calculate the strength in grams per liter and normality of 30 volume hydrogen peroxide. 30 volume means what? What does 30 volume mean? 30 volume means if I take over here 1 liter of hydrogen peroxide solution, it will give me 30 liters of oxygen at STP. So this is what you have to remember. Now we know the gram molecular mass of hydrogen peroxide is 68 grams. So 68 grams of hydrogen peroxide, it is giving 22.4 liters of oxygen at STP. So I write a sentence. 22.4 liters of oxygen at STP is given by 68 grams of hydrogen peroxide. Therefore, 30 liters. They are saying 30 volume. Therefore, 30 liters of oxygen will be given by 30 into 68. This 30 into 68 divided by 22.4 will give me 91.07 grams. 91.07 grams of what? Oxygen. Okay, so hence the strength of the solution is 91.07 grams per liter. That is how you calculate the strength. Okay, now to get the normality, the formula for normality is NEB by 1000. This is I've done in the first chapter, some basic concept of chemistry. So here, putting all the values, W is 91.07, this is W, okay, in grams per liter, and E, the equivalent weight is 17, and V is 1000. Why it is 17? H2O2. 16 to the 32 plus 2 34. 34, half of that is 17. That is the equivalent weight of hydrogen peroxide. That is 17, and volume in 1000 centimeter cube. So putting all the values, we can get the normality is 5.36 normal. Okay, so this sum you practice. This sum. Okay, you practice it carefully. Okay, this was using volume. Okay, so remember 30 volume of hydrogen peroxide solution means if I take 1 liter of hydrogen peroxide, it will liberate upon decomposition 30 liters of oxygen gas. That is to be kept in mind. So every time you have to make sure you write down the equation and balance the equation and frame a sentence. 68 grams of hydrogen peroxide is liberating 22.4 liters of oxygen at STP. So frame a sentence. 22.4 liters of oxygen is liberated by 68 grams of hydrogen peroxide. Therefore, 30 liters of oxygen will be liberated by 91.07 grams of hydrogen peroxide. So using this as W, calculate the normality. Okay. Similarly, there is another example, example 9.2 from a textbook. It is saying calculate the volume strength of a hydrogen peroxide solution containing 60.7 grams per liter of hydrogen peroxide. Now this strength is given in grams per liter. Okay, so here again write down the equation. Accordingly, 68 grams, it is liberating 20.4 liters of oxygen at STP. Therefore, we know from a sentence, since 68 grams of hydrogen peroxide gives 20.4 liters of oxygen, therefore 60.7 grams of hydrogen peroxide will give 60.7 into 20.4 divided by 68, it will give me 19.995, of approximately equal to 20 liters. So 20 liters of what? Oxygen. So since 60.7 gram of hydrogen peroxide contained in 1 liter of the solution, therefore gives 20 liters of oxygen STP, and the strength of the solution is, you can call it as 20 volume. 20 volume in volume ratio. Okay. Now these two sums, these are the two types of sums which will be asked in an examination from this chapter under hydrogen peroxide. Okay. Now after that, uses of liquid hydrogen as a fuel. This part is also important. Okay, this part is also important. So you have to go through it very carefully. The liquefied hydrogen, commonly known as liquid hydrogen, has been used as a fuel for what? For rockets. The Saturn V rocket, which enabled the first astronaut to land on the moon, was fueled by liquid hydrogen. Okay. Liquid hydrogen is considered as an ideal rocket fuel. This is due to the following reasons. Hydrogen, being the lightest known gas, has very low mass. It is combustible and has a high enthalpy of combustion. The only product of its combustion is water, which can be reused by the people or by the astronauts. It is non-polluting, no harmful pollutants are given out. It is quite abundant in the form of water on the earth, so we can apply electrolysis, okay, and prepare hydrogen gas. So it requires extra precautions, but during the transport and safe storage. Otherwise, there will be an explosion. A slight spark can cause a lot of explosion. Moreover, the production of hydrogen from water by electrolytic method consumes quite amount of electricity. Therefore, it is quite expensive to obtain hydrogen from water. Okay, so that's why we apply Lenz method for the manufacture of what we call hydrogen gas. Now, the advantages of hydrogen as an automobile fuel. It releases much greater amount of energy per unit weight of the fuel. The combustion of hydrogen does not yield polluting gases. The technology required to modify internal combustion engines for use of hydrogen as a fuel is simple and does not involve any cost. The fuel cells involving the catalytic combustion of hydrogen are already in successful use and they have a very good efficiency up to 85%. Okay, so with this we complete whatever is required from this chapter. Okay, and this chapter is now complete. Now if you look at your textbooks, if you look at your textbooks over there, in your textbooks you will find that after this chapter, at the end of this chapter, you will find there are some very short answer questions. Very short answer questions you will find over there, and then try to go through the answers carefully. Okay, try to go through the answers carefully, and then there are even some what you call very short answer type questions. Answers are given over there, but most importantly, you will find objective multiple type questions also. There are around say 30 objective multiple type questions. Okay, and then there are around 15 true or false questions, and there are around another 15 fill in the blanks type questions from this chapter. So if you go through whatever I have taught from this chapter, no question will be asked outside of the syllabus. So please follow strictly the syllabus and then learn accordingly. Okay, now with this I would like to end my class here only, my dear students. Okay, and in the next class, that is on Monday, I'll be discussing with you all. I'll be starting the new chapter from inorganic chemistry, which is called S block elements. It is called what? It is called S block elements. Okay, so now here I want to show you the questions from the back of this chapter, the questions which are important required for you all. Please go through this carefully. Wait. Yeah, very short answer questions are here. It is on page number 585. Okay, answers are given. After this, hints and answers are given. Others which is there in the syllabus, those answers only you find out. Okay. After that, page 586, short answer type questions are given. Okay, try to solve some of them, whatever is there in the syllabus. Like question number 10, Lenz process manufacture of dihydrogen. That is important. Understand by softening of hard water, number 38. Okay, number 39, number 40. Okay, number 41. Okay, these questions are important. Then after that, page number 588, long answer questions. You may go through some of them. Okay, then most importantly, objective multiple choice type questions are there. So the answers are given. So just solve them, tick the correct options, and try to learn them up. Okay, try to learn them up. Okay, like calgon is used as a water softener. What is it? What is the formula of calgon? I have discussed this already. That is number 10. What is the answer? Tell me. You have learned this already. Number 10, calgon. Huh? What is the option? Yes. What is the correct option? The correct option is this one. This is the correct option over here. The first answer. Calgon is this one. Okay, remember this. Okay. So that is how you have to solve the answers, get the answers correctly. So try to tick all the correct answers. It will help you in your examination. And then there are some true and false, 15 of them. Answer is already given. So what is true, what is false, you can get the idea from there. Like for example, 15. Interstitial hydrides are formed by transition elements. It's true. And there are, it is true. Okay, that way. And then there are some fill in the blanks which will help you in your multiple choice question as well. Okay. What is the bond angle in water molecule? Do you remember? What is the bond angle in water molecule? Does anyone remember? Yes? Can you hear me? What is the bond angle in methane molecule? What is the bond angle in methane molecule? The bond angle in methane molecule is 109 degrees 28 minutes. So what will happen to the bond angle in water molecule because of the presence of two lone pair of electrons? Yes. Will it increase or decrease? Yes, voice. Are you there? Yes, Aditya Chetri. What is the bond angle in water molecule? Yes, it is 100 and it is 104.5 degrees. It is 104.5 degrees. Okay. So that is how you're going to get your solve these questions. It's number 11. It is given 104.5 degrees. Okay. And there are some assertion reason type question. These questions are normally asked in the competitive examination. You may go through them as well. Okay. It will help you in answering questions during your competitive examination. Okay. So with this, we come to the end of the chapter, and I would like to end my class here only. Okay. But please hang on. I would like to record your attendance first, then you may leave the class. So on Monday, I will start the next chapter, that is S block elements. Okay. The attendance is downloaded. So thank you so much. Have a nice day.